This is Mrs. Downey, and this is part 2 of our semester 1 final for Algebra 2. The number 21, we did 21 through 20 yesterday. 21 says solve the system by substitution. So we're going to start by picking one of the equations, and pick the one that's got the least amount of math to it. So of course, this is our obvious choice, and solve it for one variable. I'll solve it for x. So you have x minus y equal -2, just copying it down, and we want to solve it for x. So we have to add y to each side. And when you do, you get x equal y minus 2. So now we've solved for one variable. X equal y minus 2. Okay, now we're going to take x equals y minus 2 and sandwich that into the other equation. So we've got an x minus 2y equal -6. So everywhere there's an x, we're going to replace it with y minus 2. So doing that now, we've got y minus 2 minus 2y equal -6. Now just solve. So we have a y minus 2y, combining our like terms, that's like a 1y, it becomes -y. And then minus 2 equal -6. Okay, now we want to continue to solve, so add 2 to each side, and you get -y equals -4. Divide both sides by 1, and you get y equals a +4. So we have part of our equation. We've got the y part. Now let's plug that back into either equation and get our x value. Oh, but look here. We've already solved that equation for x. So we said x is equal to y minus 2, and we just said y is equal to 4. So x is equal to 4 minus 2, which is 2. So there's your answer. 22 says solve the system of inequalities by graphing. So we have two simple equations here. We have x is greater than or equal to -3. Because it's also equal to, we're going to make it a solid line. So what that means is go to the x-axis and put a line through it at -3. So if I have -1, -2, -3, we're going to go to this x-axis and put a line, solid line through it at -3. And it's greater than, so we're going to shade to the right of it. So shade, there we go. And the next equation says y is greater than 4. So you want to go to the y-axis and put a line through it at 4. So here it is. And this is going to be a dotted line because it's just greater than. It's not equal to, it's just greater than. So it's just going to be a dashed line showing that this boundary line, any point on the boundary line, is not included in our solution set, but everything greater than that is. So let's shade. Let's pick this one. And it's everything greater than. And this goes on forever and ever up and to the right. Now the solution of these inequalities is where they overlap. So let's pick a different color and color those. Yeah. So it's going to be here. So up and out forever and ever, this way and upwards. Okay, but remember that this is a dashed line here and a solid line here. Our next problem says solve the system by elimination. Excuse me. So we have a 3-variable, 3-equation system. So what we have to do is eliminate, pick 2 of these and eliminate a variable. Well, when I look at these, I see that the first one and the third one, they both have a 5x, a -5x. So I'm going to pick those 2 first. So let's label these so I can refer to them as equation 1, equation 2 or equation 3. So I'm going to use equations 1 and 3. So negative 5x plus 5y minus 2z equal negative 9. And then my third equation, negative 5x plus y plus z equal 4. Now I've got to subtract these to make my x eliminate. So instead of remembering to subtract every single term, I'm just going to go ahead and distribute a negative 1 across every term. So when I do this, and then I will add. So this becomes a positive 5x. This becomes a negative y. This becomes a negative z. And this becomes a negative 4. So now we have, oops, we're going to add these together now. That was a positive. Okay, so this goes to 0, so we eliminated x, and this is going to be a 4y minus 3z equal negative 13. And now we've eliminated one variable, our x, with equations 1 and 3, and we're going to call this equation 4. Now let's do that again with our equation that we didn't use. And it doesn't matter which one you use again, as long as you just pick the second one and pick 1 or 3. Well, again, I'm just going to pick 3. So I'm going to use 2 and 3. So 20x plus 4y minus 5z equal negative 7. Okay, and then my equation 3, negative 5x plus y plus z equal positive 4. Okay, now again, I've got to eliminate the same variable in my next equation. So if I eliminated x in the previous, which I did for number 4, now for the next equation, number 5, I've got to eliminate the same variable. So I've got to eliminate the x. Well, these aren't the same, so you have to make them the same. But whatever you do to make them the same, you have to do it across the whole equation. So I have to multiply my second equation by a 4 to get these to be opposite. So when I do this, I'm going to get a negative 20x plus 4y plus 4z equals 16. Now that I've rewritten this, I can get rid of it. And now I can move this guy up here. Okay, and now when I add these, my x will eliminate. And so I've got that's going to be an 8y minus z equal 9. So now I've got my fourth and fifth equation, and I've eliminated a variable. Now let's do it one more time. With our equation 4 and 5, let's eliminate either y or z. And I'm just going to eliminate our y. So I've got this, and I'll just put it down here. All right, so now let's do this. So what do I need to do to eliminate my y? Well, I'm going to multiply it by a negative 2. And I'm going to multiply everything by a negative 2. So I'm going to get a negative 8y plus 6z equal positive 26. So now this goes away. I'm going to move this up. All right. Now, when I add them, I eliminate my y, which was my goal. So this is going to be 5z equal 35. So z is equal to 7, dividing both sides by 5, right? So I've got one of my answers. I've got my z, which is a 7. And we're looking for our x, our y, and our z. That is the answer right there. But I'm just showing you how we get it now. So now let's go back that we've got our z for 7. Now pick equation 4 or 5 and plug in your z of 7 and get your y. So I'll just use equation 5. 8y minus z equal 9. And we said that z is equal to 7. So it's going to be 8y minus 7 equal 9. We'll add 7 to each side, and you get a 16. So 8y equals 16, divide both sides by 2, and you get y equals, by 8, divide both sides by 8, and you get y equals 2. So now we've got a z and a y, so now we've got y equal 2. Now we've got to plug in our y and z into one of our first equations, and you'll get your x. So let's do that. So I'll just use the bottom equation again. So minus 5x plus y, which we said was 2, plus z, which we said was 7, is equal to 4. And now that's going to be a 9. And subtract 9 from each side, and you get a negative 5. So I get negative 5x equal negative 5. So divide both sides by negative 5, and you get that x equal 1. So that's how you get all 3 of your answers. And that's it. Your solution is 1, 2, and 7. Our next equation says graph the function. How is each graph a translation of f of x equal x squared? Well, we know f of x equal x squared makes the parabola that I'm showing here. And we look at this equation, and we have y equals x plus 2 squared plus 1. So the parent function here is y equal x squared. There it is. So what's different is we have an h value and a k value. H is our horizontal movement, and k is our vertical movement. So we've got a positive 2. Well, that came from x minus negative 2, right? Because our formula is x minus the number. So we're moving to the left 2 from the parent function, and we're moving upwards 1. So we're going to take our parent function graph, and we're going to go to the left 2, 1, 2, and up 1. So there is the translation of the equation. Number 25 says what are the vertex on the axis of symmetry of the equation? And we've got, you can do this 2 ways. You can plug it in the calculator and look at your table of values after you graph it. And in your table of values, your y value would be going down, 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 smaller, smaller, and then it's going to hit a lowest point, and then it's going to start going back up. Okay, so you want to look for where did it go. So was it like 6, 5, 0, and then it goes to negative 3, and then back up to 0, 5, 6. So you want to look for that lowest point, and that would be your vertex. So you would get whatever that value is, the xy coordinate would be your vertex, and that x value is your axis of symmetry. Now, there's an easier way if you don't want to use the calculator. So we had a vertex formula that goes negative b over 2a. So to make this easier, I want to factor this guy first. So if we notice that all of these are divisible by 2, so we've got y equals 2 times x squared plus 14x minus 1. And remember, we're going to use our negative b over 2a for our vertex. Our vertex formula. That's going to help us get our x value. So what we do is we decide, okay, well, we've got an a value equal to 1, b is equal to 14, c equals negative 1. So let's plug it into our vertex formula. So we've got negative b, which is 14, over 2 times a, which is 1. So we've got negative 14 over 2. Because 2 times 1 is 2. So our x value is equal to negative 7. So that's our axis of symmetry. So here, I'm going to replace this with my axis of symmetry. So our x value is -7, and we know our axis of symmetry is x equal -7. Now we're going to plug this back into the original equation, which I have right here, and solve for y to get our y value. So we've got this is equal to 2 times -7 squared plus 14 times -7 minus 1. So now we've got a positive 49 plus 7 times 4 is 28, so -98 minus 1. So that's going to come out to -9. Oh, excuse me, that would, when we distribute the 2, we haven't done that yet. Okay, so we've got -99 plus 49. And actually, that's going to come out to be, well, -99. Yeah, let's write this. 49 minus 99 is just 50, -50. And each time we're multiplying by 2. Don't drop the 2. So 2 times -50, whoops, is -100. Okay, so that's our y value, -100. Okay, so there's your axis of symmetry, x equal -7, and your vertex is -7, -100. And that's your answer. 26 says, what is this expression in vector form? Well, this is a simple trinomial, and you look at your c value 12. What two factors of 12 add up to be our middle value, our b value, 7? What would be 4 and 3? When they're multiplied, 4 times 3 is 12, 4 plus 3 is 7. So it's going to be x plus 4 times x plus 3, or vice versa. That's your answer. Here, close to our last one, but it's not in standard form, so we have to do that first. What are the solutions of this quadratic equation? We have to put it in standard form first, so add 20 to each side, and you get x squared plus 9x plus 20 equal 0. And now we have to solve for that. So on this trinomial, what two factors of 20 add up to be 9? Well, it's going to be 5 and 4. So x plus 5 times x plus 4 and equal to 0. So what makes each one of these true? When x is equal to -5 or -4. So these are our solutions. 28 says, what's the solution of each equation? Just solve for x. So divide each side by 4, and you get x squared equal 4. Take the square root of each side, and you get x equal positive, negative, radical 4, and radical 4 is just 2. So positive 2 and -2. 29 says use the quadratic formula to solve the equation. So our a, make sure it's in standard form. It is. So a is equal to -4, b is equal to -10, and c equals -4. So we're going to do the quadratic song. The x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So there it is. Now let's just do our number crunching. So use a different color. So x is equal to, that goes to positive 10 plus or minus the square root of that goes to a positive 100, and excuse me, okay, minus, that's -4 times -4 is positive 16 times 4 becomes a -64. Well, over 2 times -4 is just -8, now. 100 minus 64, 100 minus 60 is 40. Take away 4 more, and that's 36. So square root of 36 is just 6. So we end up with x equal 10 plus 6 over negative 8 and 10 minus 6 over negative 8. Okay, so this is a 16 over negative 8, so this becomes negative 2, and this becomes a 4/8. So and this one's negative 1/2. So negative 2, negative 1/2 is your answer. 30 says simplify the number using an imaginary unit I. So we know when we have a negative sign under a square root radical, that pulls out of here, creates an I. So we have I radical 9. And the radical of 9 is 3. So we have I times 3, which becomes 3I. That's your answer. The next problem says write this in standard form. So we have to distribute this 2x squared to these two terms in the binomial. So we have 2x squared times negative 4x squared. Well, this can be a negative 8x to the 4th. Remember when you multiply powers of the same base? When you multiply them, you just add the powers and keep the base. Okay, that was just an example, not the problem. Oops. All right, so now to the second term, it's going to be plus 10x to the 5th. All right, now it says write it in standard form. Well, the highest power goes first, so it becomes 10x to the 5th minus 8x to the 4th. And that's your answer. Our next problem says what are the zeros of the function and graph the function. So it's written in a way that we can very easily find our zeros. So you set y equal to 0 and solve for each one. Well, what makes this one 0? When x is equal to negative 4. And for the next one, a positive 4. And the last one, a positive 5. So there's our first part. So there's the zeros to our functions. Negative 4, 4, and 5. So now when we graph these, we're going to put a dot on the x-axis at each one of these points. That's our zeros. When y was equal to 0, that means it's on the x-axis, right? So at negative 4, a positive 4, and a positive 5. So there's our 3. Now to graph it, we have to decide what's happening between these points. Is it going up or down? So pick a point in between the two and see what's happening. So I'm going to pick 0. So pick a point in between. Let's just pick 0, right? So when x is 0, when we set x equal to 0, what is y? Okay, so let's see. When x is 0, you have 0, 0, 0. So you have 4 times negative 4 times negative 5. Well, negative 4 times negative 5 is a positive 20, and positive 20 times 4 is an 80. We can see it's going to be a very large positive number. So it's moving way up here. So it looks like it's going to be going up like this, and then it will be falling back down this way. And now let's look what happens between 4 and 5. So pick 4.5. We expect that it's going to be negative, right? It's going to fall below the x-axis. So when we look at this, we've got 4.5 plus 4. That's going to be an 8.5 times 4.5 minus 4. Well, that's just going to be a times 0.5. And then a 4.5 minus 5 times a negative half, 0.5. Well, positive times a positive becomes positive, and positive times a negative becomes a negative. So our last number is going to be a negative, so it's falling below. So that's what we thought. So it goes up. So from down, up, down, up. So that's our graph and our zeros. -4, 4, 5, and this is our graph. So plot the zeros, look at the points between. Are they rising or falling? And like I did, you don't even really have to look at the actual numbers if you can just tell from is it rising or falling. For number 33, we say what are the real or imaginary solutions of the polynomial equation? Well, we're going to look at our first two terms, and they both share an x squared. Well, the third term does not, so we can't just totally factor it out of the whole equation. But we can factor it out of the first two. All right, so what we will do is use a little trick. We're just going to let a equal x squared. Then if we do, we can rewrite this first term as a squared, right? Because if a is x squared, then that's x squared squared, which is x to the fourth, minus 25a, and if we fill in our a, it becomes 25x squared, plus 144, which doesn't contain any x squared, equal 0. All right, so we've got this, I'll move up there. All right, so now we're good to go. So now when we factor this, we have to say, well, what two factors of 144 add up to be a -25? And when we do that, we're going to find it's -9 and -16. So we can rewrite this as a minus 9 times a minus 16. Boy, it's messy. Equal 0. So now let's put our substitution back in. So what was a? X squared. So x squared minus 9 times x squared minus 16 equals 0. Now let's factor each one of these. They're both the difference of squares, right? So this would be equal to x plus 3 times x minus 3 by our formula of difference of squares, and this one would be x plus 4 times x minus 4. So what is our answer? Positive -3 and positive -4. Because you have a positive 3 for this one, -3 for that one, -4, and a positive 4. So these are our zeros. So everybody did a poster on these, so I'm not even going to go through this. It's dividing using synthetic division. And when you do, your answer becomes -3x squared minus 3x minus 7. And I want to point out one thing on the posters. No matter how you divide it, if you divide using long division, which would be the x plus 3 into that whole polynomial equation, or you do the synthetic, your answer should be the same. It shouldn't change just because you change your method of solving. Set 35 says use the rational root theorem to list all possible rational roots of the polynomial equation. Do not find the actual root. So we're just looking at the possible actual roots. So this is quite easy. You look at your first coefficient, which of x cubed is just a 1. And our last term is a -3. Okay, and actually it's going to be the positive and negative of all these. So now we call that our P, and this is our Q. All right, so now we want to find all the possible combinations of P over Q. So we're going to have a positive 3. Let's just do this. Positive and negative 3 over 1. And what are all the factors of our P is 3 times 1, and factors of 1 is just 1. So we've got 3 over 1 and 1 over 1. So our answers are positive -3 and positive -1. All right, remember, it's the factors. I almost left that off. So the factors of these. So 1 only has one factor. 3 has two factors, 1 and 3, because 1 times 3 is 3. But for Q, we only had a 1. So 1 times 1 is 1. It has one factor. So all the possible combinations of P over Q becomes 3 over 1 and 1 over 1. And you do the positive negative of both of those. So that's how we got our answer. A polynomial equation with rational coefficients has the roots of 2 plus rad 4 and 5 minus rad 4. And find two additional roots. Well, we just flip these signs in front of the radical signs, or just the complex part. So it's going to be 2 minus rad 4 and 5 plus rad 4. And that's our answer. 37 says find all the zeros of the equation. It's quite a long polynomial, so we're going to plug this into the graphing calculator to get our push start. So when you plug this in to your y equals in the graphing calculator, here it is, and you hit graph, you get this. Now there's your zeros where they cross the x-axis. So you would look at your table to verify. It looks like it's at 0, and those are a little hard to read. You could let's look into the table and look for our zeros. And we know 0 was one of them. So, let's see. Okay, I had that typed in wrong, and I've corrected it. So, I was missing the cube right here. So I noticed there was nothing coming out in my tables as you saw in the data. But when you graph it now, you can pretty much see it's looking like it's at -5, around 0, and 5. So you can, again, check your table, or you can calculate your zeros. So, oh, there's one at -5. Oh, there's one at, I'm looking for zeros. There it is. 0 at 1 and 5. So -5, 1, and 5 are our zeros. -5, 1, and 5. So now we're going to use our synthetic division to take each one of these out of this equation. So here we're going to do a -5. And we know those came from the equations x plus 5 equals 0. X minus 1 equals 0, and x minus 5 equals 0. Okay, that's where these came from. And we're trying to find, well, what do you multiply? What's the leftovers to multiply all this together and get this equation? Okay, so there's 2 more zeros that we have. And why do we know this? Because we got 3 of them, and this is a 5th term. So we've got 2 more to find. So we're going to divide all 3 of these out. I'm going to pause and come back. Okay, so there it is. That's the coefficients of every term here. 1, -1, -24, +24, -25, and +25. So now start by carrying down your 1. I'm going to do this one time. Multiply. -5 times 1 is -5. Get a -6. Multiply. 30. And then you get a +6. So -30. And now we're going to get a -6. So again, 5 times, that's going to be a +30. Add them, and you get a +5. So -25. And the last term should be a 0. That's always going to be your remainder. Okay? And because it is a factor, there should be nothing left over. Okay? So now we've whittled away one of our zeros. Now let's do the next one and the next one. And I'm going to pause the video and come back. I want to point out we're taking out the 1, so you use what was left over to keep whittling down. So 1, -6, 6, -6, and 5. Now repeat the process. Okay, and now we've done that one. Now we're going to take out the next 0, which is our 5. So we end up with, that's our remainder, should be 0. So that's our constant, our x squared, and our x squared. Our x term and our x squared term. So it's 1x squared plus 0x plus 1, which turns into x squared plus 1. Now let's solve that, because we're still looking for 2 more answers, right? We've got to solve for x. So set this equal to 0 and solve. And when we do that, whoops, okay, so we're going to get x squared equal -1. Take the square root of each side, and you get that x is equal to positive negative, and square root of -1 is just I. So it's going to be a positive I and a negative I for your answer. And those are our zeros. So -5, 1, 5, I, and -I. And those are all your zeros. That's how you do it. 38 says use the binomial theorem to expand the binomial. So we want to start off by looking at what we have here. So we have a binomial to the third power. So we know we're looking in our Pascal's triangle at the third row. Remember, it starts with 0. So that's 0, 1, 2, 3. So the third row is 1, 3, 3, 1. So we know those are our coefficients. Goodness. So now we know that our a term is equal to x, and our b term is -2y squared. So we know it's going to start with 1ab, 3 plus 3ab plus 3ab plus 1ab. Now let's number everything. Remember, the a's start with the highest power, 3, and they whittled their way down to 0. 3, 2, 1, 0. And our b's start at 0 and work their way up. Now let's get rid of our b to the 0 and a to the 0, because that's just 1. And now, so we've got a cubed, and our a is x, so we've got x cubed, now we're just substituting, plus 3 times a squared, a is x, and our b is, we're going to substitute -2y squared, plus 3 times a to the first power, a is x, times b squared. So our b now is -2y squared squared, because it's b squared, plus 1 times b cubed. Well, b is -2y squared cubed. Now start simplifying. We've got our formula in. So it's going to be x cubed, use a different color, x cubed plus, and now we've got this times this. So it's going to be 3 times -2, that's going to be a -6, and x is by itself, and y squared is by itself. And I like to put x before y because it's in alphabetical order. So that simplifies to x cubed minus 6xy squared, right? So now we're done with those. Now let's keep going, plus, now we've got this to contend with before we do anything else. You've got to take care of your powers, right? So this is going to be 3x times, well, that is like a -2 squared, which is -2 times -2, 4, and y squared squared. Power to a power, multiply the power. So 2 times 2 is 4. It's going to be 4y to the 4th power. Okay, and plus, and now we've got the same thing. -2 cubed is 2 times 2 is 4 times 2 is 8, so it's going to be a -8, and y squared to the 3rd power, power to power, multiply. 3 times 2 is 6, so y to the 6th. All right, now let's finish it out. 3x times 4y to the 4th becomes 12xy to the 4th. So that one's done, plus Actually, it's going to be a minus because it's plus a negative. So negative 8y to the 6th. And if you have any more like terms, you can combine them, but this is your answer. 39, you're going to plug in your x coordinates and your L1 statistics. So you would have -2, -1, 0, and 3, and you put your y coordinates in the L2 in the second list, -7, 4, 5, and 8. And then you're going to start your regressions. And when you do that, you'll find that the linear regression didn't match up much. The only one that really matched up to these, don't forget to turn your stat plots on, is the cubic regression. And this is it. Our last problem, 40, says, right, what's an equation of y equals x cubed with the given transformations? Well, remember, this is going to be something like y equals a times x minus h cubed plus k, right? So it says a vertical stretch by a factor of 3, so that's your a value. So this is going to go to 3. A horizontal shift 8 units to the right. So it's moving 8 units to the right, this way, 8. So our h is equal to 8. So we have y equals 3 times x minus 8. And a vertical shift 3 units down, so a -3. So plus a -3. So this is your answer. And that concludes our test. Thank you for watching.